you to make that suggestion. You didn't suggest Monday through Saturday.
I kind of phased out when you were talking about dates.
It's terrible.
Monday through Saturday.
The 4-hour 325 class that starts meeting at 5:30 a.m. next semester.
It's not relevant to me either.
I've seen classes that meet on like a Sunday before. You can do that.
Yeah, but this is Monday through Saturday, and it's 4 hours per day.
How many credit hours is it going to come as?
It's a 1 credit hour class. All right. So today we were writing, or for today we were writing the first part of our web server, right? So with the shut up. My wife and I were watching this show called AP Biology. It's on TV now. I guess only the first couple of episodes have been on. It's really funny. It's about this like, I don't know, renowned Harvard professor that gets passed over for tenure, so he quits or something. So now he's like teaching this like high school biology class and living in his mom's old apartment or something. But he has no interest in biology, so he's just checked out. But when he shows up to class, he always says, "Okay, let's start shutting up," or so, like my wife said that I should adopt some of those protocols into the class, like warn you ahead of time to begin the shutting up process. Good news is I record everything, so you guys have all the evidence you'll need. All right, let's see. What class is this? 450? All right, so we're writing our first part of our web server. So let's review what that's all about here. So we are going to be creating this dude that sits over here, server, okay? Specifically, we're going to be making a web server, and that is a dude who speaks HTTP, right? That's ultimately what we're creating, all right? Now, what we have right now, well, what we should have, what you should have submitted today is this idea where we have a local user. All right, so this is just an interactive program. We're sitting there at the thing. So this local user, the server starts up, asks the local user for input. Doesn't even prompt them because a normal web server isn't giving them an initial prompt. It's almost like security through obscurity. You connect to this this port, and the port's just silent, but the connection's been established, and then you have to kind of say, "Hello." You start the conversation. So this guy is going to start that conversation by spitting out one of our simple HTTP commands. So he's going to spit out something like a get index.html, for example. All right. The server is going to receive that. And then when he receives that, he's going to read in. Well, he's going to have to parse this string, right? And take out he'll look at the first piece and say, what is it that you want to do? For HTTP, we have 4 functions. We have get, put, post, and delete. Well, we're only looking at gets right now. And we aren't even implementing HTTP yet. So that's more just foreshadowing stuff. We've talked about this in other classes in terms of REST APIs, and maybe something else I don't know if I've shown you before, but REST APIs follow something called CRUD, create, reuse, update, delete. Okay, so that's what REST APIs do. So this is in terms of get, put, post. Well, so this would be create is going to be a put. Was that right? No, that's update. So create is going to be a post. Reuse is going to be retrieve, not reuse. Retrieve is going to be a get. update is going to be a put, and delete is going to be a delete. So those are the 4 functions associated with HTTP. Now, the reality is most of those functions haven't been used for a while. Well, hadn't been used for a long time until more recently. Really, when we were working with HTTP, we're doing gets and we're doing posts. Those are the 2 things that we are using for form retrieval stuff. But we're going to start off with just some gets. So we're giving our simple little HTTP command. So you're going to read in a string that looks like this. You're going to piece that into 2 pieces. So you're going to convert that guy into that guy and that guy. 2 separate pieces, right? This guy is going to be our command that we're going to maybe use later. So we're going to ignore it for right now. What we really care about right now is the name of the file, because this is the guy we're going to try to open up for reading from our local file system. So this web server, well, soon to be web server, is going to have a whole bunch of files here. Maybe this is called file1.txt, and then maybe he has a file2. And maybe he has an index.html. And then I put up on Slack, maybe we also have like an error.html that we assume is there, that we go ahead and read that in the event that they ask us for a file that's not there. Okay. So we're going to see what file do they ask for. We're going to try to open that file for reading. If we are able to successfully open it, then we're going to spit it back out to the screen. Just print it to the screen, display it to the screen. Oh. Display to screen for right now. Okay. So, request something, try to get it, display it to the screen. We'll either display the contents of the file they asked for, or we'll display error.html. And this is just going to be dumping out to our screen. What we'll do next is we're going to, right now this is just doing normal file I/O. Well, this is doing normal user input and output, standard input, standard output. But we're going to take this user and make them remote, or at least compatible with being remote. And then we're going to use sockets to do the communication between these. All right, so let's write this first piece. So we need to initially read in an HTTP command, and we need to piece out the parts of this, right? So let's start with that piece. All right, so we'll do this inside of test. I've already kind of created a socket server for us to walk through. We might not get to it today, but whatever. All right, so I'm going to create a function here. It's got to be a char pointer, and we'll call this guy parse HTTP. Makes a pretty good sense. This guy will take in a char pointer as a parameter and an int max size. Okay, so we're presuming that S is going to hold something like get index.html, something that looks like that. Go ahead and surround it by double quotes. All right, so something along those lines. And what we want to do is we want to get 2 pieces. We want to get one piece that has get in it, and we want to get another piece that has the index.html in it. Make sense? That way we know the name of the file that we need to be able to read in. Okay, we could always choose what's going to come out of here later on. We might end up doing a struct or something, but for right now, we just need the file name. Okay, so we're going to initially read it in from the user. So we do that with a scanf. All right, so we're going to need to create a char pointer. Call this guy user input, and maybe make this guy, Actually, the way I'm writing this, we're going to read this in someplace else and then call this. Let's come up here. I'll just save our file IO stuff so we can easily grab it here in a few minutes. All right. So we'll go ahead and create a char pointer, user input, and this is going to equal char pointer version of malloc. And then maybe we want to say, we'll create an int buffer size and set that equal to 100, something like that. Okay. So we'll go ahead and read in buffer size times size of char. That's the amount of memory we're going to go ahead and set aside for our input. Then we'll go ahead and do a printf prompting. Well, actually, we're not prompting them, right? We're not prompting them from this server. So we'll just do a scanf. So our program is going to initially seem pretty dumb, right? You're just going to be sitting there at a prompt and like, okay, what is it? So we're going to do a scanf, and we're going to be reading in a string, and we're going to read that into the address of user input, or all that random crap that I just put in there. User input, there we go. All right, and then just to like prove it got read in right, let's just do a printf %s \n, comma, and then we'll pass it the value. Actually, we don't need the value. We'll just say user input like that. Okay, so we'll type something in, press enter. It should spit it back out to the screen. Let's go ahead and run this guy. So we'll do gcc test.c. Didn't like all my... I have extra comments inside of comments here. Should be happier now. All right, so it's sitting there, not prompting me for anything, but it's blocking. So this would be called a blocking program, right? It's waiting for something. So I'll just type in LOL, press enter, and we get a segmentation fault. So do I need to print out the value at user input?
In your scan, did you actually want to say address? But do you want the ampersand?
Aren't you reading it into an address?
I think when it's a string, you don't need that.
So you need it for an int, but not a string.
Right.
Because this is going to be the, yeah, that's just the value. All right, perfect. So now we're reading crap in and spitting that crap back out. So the idea would be we would read something like index.html in here, and then it would, oh, interesting. So this is going to actually be perfect. I forgot about scanf. So scanf will actually allow us to read in both pieces. So we can, instead of saying user input here, we can say command, and then we can say char pointer, file name, and let's say probably being a little bit large there for the command, since we know the maximum size of an HTTP command. So we can call this guy file size. We can call this guy command size, which will be equal to the length of delete, right? DELETE 6.
+1.
Oh, yeah. So command size, so this is length of delete +1 for \0. So now we'll say command is going to be command size. We'll say file name will be file size, and it's reasonable to assume that we're not going to allow for a file name longer than 100. File systems usually actually have some sort of limit, but I don't know what it is for Unix these days, but 100 should cut it. Okay, don't make a file name longer than 100. Okay, so we're reading stuff in, but what we're going to do is we're going to read in two strings. We're going to read in a string and then another string. The first string is going to be read into command. The second string is going to be read into file name. And then we'll go ahead and print out the command. And we'll print out the file name. Proving we read in the 2 parts. Compile that guy, run this guy, get index.html, and there's our 2 pieces. All right, so we don't need our little parser there, but it would have been cool to write, right? to write our parser. So in any case, yeah, so there's another function in C++ called getS that wouldn't have given us the scanf. Actually is a pretty cool function that lets you break it into this. GetS in C++ would have given us the whole string and we would have had to parse it. Okay, so we don't need this dude anymore. So we probably want to have a function that's going to try to read in a file that we can kind of piece out our individual pieces. So, and maybe this guy will, well, we'll have him return a, this one is going to be a little bit, yeah, and just do it all in one fell swoop. Makes enough sense. So we'll do, actually, it's always going to succeed even if it prints out an error. So we'll do void get. This guy is going to take in a char pointer, file name, and an int max size. All right, and this guy is going to attempt to open up that file. So we're going to need a file pointer like we had up here. So we'll go ahead and grab that dude. There's our file pointer. We're also going to need to try to open that file for reading. All right, so now we need to throw in here the / input txt. So we need to build a string with that guy in it. You probably could get away with just doing it local. So he's saying that you can actually read it like that. If you're saying that works on here, that's fine. That's maybe a little bit dangerous. We'll go ahead and go with it just for time. But / we talked about what the dot directory is. That's a symbolic link back to the current. Actually, it's not a symbolic, it's a hard link back to the current directory. But regardless, in the event that we were on a file system that required that, we would need to expand this string to include that piece on it. So we'll find, so instead of input txt here, we're just going to give it the file name, in which case we probably don't actually need max size here. So we can go ahead and dump that right now. All right, so we'll give it the file name for reading. Now let's go look at the man page for fopen. And I think we saw that gives us a null if something bad happens. I hate looking at it on there. We saw last time it gives us a null, right? Okay. Well, you could actually do this. You can say, what you'll often see it written as, you'll see if that, then do some stuff. All right, so this if statement will only proceed if the value that's returned is not null. We typically don't think of nulls as being part of a Boolean expression, but in C they are. Okay, so we can say, if this works, so we're trying to do that. And if you look over here in my server code here, you see we're trying to do the same stuff. So they're actually checking its return value less than 0 on that one. Yeah, so that actually might not work here. Let's just be explicit and be sure. Yeah, I suspected it would work, but let's just be explicit instead of looking like we have strange code. So we're going to say if fp is not equal to null, like that, right? So as long as I have something in fp that's not null, that means I must have a file pointer to the real file. And now I can do stuff, all right? Because the else is going to be fail to open file, show error HTML, something along those lines. Okay. So if we're in here, we successfully received the file, so now we want to read the stuff in from the file. We probably, well, I guess we could just do it in place right here. So here's going to be our, we could basically just take this code here. So we'll read in 200 bytes at a time into this string called s, while fgetS, given the name of our string, which is fp. Well, no, we're reading into the string our destination, which is s, read size, and the name of the string is fp. While that guy is not equal to null, we'll go ahead and, this was the process string stuff. For right now, we're just going to spit it out to the screen. So we're going to say print f %s backslash, or %s, and we'll write out s. This guy should have the carriage returns at the end of it for us. If it doesn't, we'll be able to put that in. But realistically, if we're going to be writing this over a socket, it doesn't matter. The web browser will make it look right for us. All right, so because just like normal compilers, web browsers don't care if all your HTML is on one line. They're perfectly happy with that. It's humans who care about that. So we'll read in that file one line at a time, spit out the line. When we are done reading everything in, we'll go ahead and do an f close on fp. And that should do that. It might have made sense for us to put this inside of a function to do that, but since we're kind of moving forward towards doing this as a web server, we might actually be doing some different things in here. Let's just be, we'll just double up on the codes, and we only need it in 2 places. So this is what we'll do if the file name is found, correct? If it's not found for right now, we'll just do a printf. Actually, did I already give myself an error? I had it stored here somewhere, right? What's up? Is it my downloads folder? But can I drag it into whatever. We'll just create it in there real quick and be done with it. Oh, very nice. Nailed it. All right, so I have that. Go in here. We'll create a new file called error HTML. Make it all caps to make us look really important. We'll save this. Oh. There's our error or whatever. We won't have pictures, but it's just the way it'll be. All right, so now we'll go back over here to our test. We'll steal. I already have that. I probably shouldn't be. But we'll just reuse FP. So otherwise, we're going to be opening error.html, name of our file, for reading. We'll do the same stuff we did before. And close FP. All right, So that should do it for that. We do need to give ourselves a sample, like some file for us to, here's our input.txt that has stuff in it. We'll pretend like that's our HTML. So that's for get. All right, so now up here, we have our two pieces, but we're going to go ahead and we're going to call our function. We'll have to prototype this. So I'll go ahead and copy that and prototype it real quick. And we're going to go ahead and call get, and we'll pass it our file name. And it will attempt to get that file name, read it in, print it out to the screen, or show our error. Okay. All right, so we have a get. We'll do input.txt here, and there's the output of that. And you see it does kick it down a line, because it's reading the end of line characters. We'll run this again. I'll bang on the keyboard a little bit. And is it not happy? Oh, it's been a get. That's the actual file name. I had to give it two pieces of information. I didn't type in get space, so I have to give it the second s, %s. So there's my error. If you want to see it again, get, bang on keyboard. There's our error message. That make sense? All right, so that was the homework. So really this get function, all this other stuff is from before, right? So I can go ahead and gut this. Actually, I don't need to gut it because we'll be moving our stuff over to our server. All right, so questions about that? All right, so let's just walk through, well, let's talk about what a socket is for a second. I think we introduced it at some point, didn't we? Did I mention sockets at some point? Okay. So sockets come in a couple of flavors. Okay, we have stream sockets and we have datagram sockets. Okay, so in real life, stream sockets would be used when we move data across a network and we care about missing stuff. Datagrams would be used when we move data across a network and we do not care about missing stuff. So datagrams would be used for video streaming, that kind of stuff, or even real-time video games. You know, if you're putting in, you know, your position of your characters being sent over the network or something like that, and you know, typically you're getting 60 millisecond ping or something like that. If you drop one position in those 60 milliseconds, that's not the end of the world. You probably don't want to spend time resending your position because you're already in a new position. Where stream sockets, if you're transferring a file and you expect that file to be not corrupt on the other end, you probably want that. So this is really the idea of TCP/IP versus the idea of, what's the other guy? UDP. These are datagram packets. Okay, so those are the networking pieces of that. So as an example, well, let me run this program for you real quick, and then we'll go through and see how it's working. So I already opened up a couple of different terminals. All right, so over here, what was the last thing I ran over here? Okay, so so I'll clear this. So I have a file in here called server.c, so gcc server.c, and then we'll go ahead and run this. So it's now waiting. So this looks similar to what we just did, you know, in our program, right? But what it's done is waiting for an incoming connection over the internet. All right. So now I went ahead and I went up to, I think, Window, and I said New Terminal. So this gave me a second terminal down here. So I can do another thing. So I'm actually going to connect to my same machine, but I actually am going to go out. I'm going to leave the machine and come back to the machine. Because we can connect to the same machine if we do, we're going to use Telnet to do this. If I say Telnet localhost, I'm going to type in 8080 because that's the port it's listening to. I'll show you why in a second. I'll press enter. This guy connected to it. I'll go ahead and type in LOL, just type something in. This guy's being, and here's the server. The server's responded back to me, okay? But by using localhost, similar to localhost, let me show you the other equivalent to it. Notice what the output here is. Hello, message sent. So instead of using Telnet to localhost, anybody know what the equivalent of Telnet localhost is? 127.0.0.1. If you've ever seen the geek shirt that says there's no place like 127.0.0.1, that's home. There's no place like home. Haha. All right, so localhost is the synonym for 127.0.0.1. All right, so that goes to the exact same place like this. Okay, so same program ran. Now, if I want to actually leave the computer and be routed back to the computer using the internet, I have to know the IP address of this machine. So my server is currently waiting for the phone to ring. I'm going to do a command here called ifconfig. And so notice it shows me the different interfaces here. This is the internet is it internet interface or just IF as interface? Whatever. It's whatever it is. Here's the 127 for loopback. Here's the actual IP address of this guy. Let me copy it. There we go. All right, so this machine is live on the internet. Its IP address is 172.31.7.41. That's my Cloud9 machine. Okay. So this shows me all the different pieces. This thing's running on a virtual server, so this is kind of its network host, but regardless of any of that stuff, I'll go ahead, I'm going to say telnet to that address, port 8080. And because that's a routable IP address, I will actually leave the computer, hit the router. The router will notice that guy, well, actually it won't. It depends on how the router's set up. It might actually leave their router, hit the next router up, which will then route it back to their network and get back to the machine. So I'm talking to a local program, but if your internet is down, this wouldn't work. Because you wouldn't actually, you'll leave the machine but never be able to get routed. All right, so now the server could be in Moscow. All right, so we'll press enter there, connected to it, LOL, spit it back, see the server responded. Make sense? All right, so 3 different ways of talking to the server. 2 of them are the same localhost and 127.0.0.1. That's the local loopback IP address that says don't leave this computer. That will always work. You don't need an internet connection for that to work. The other one is by actual IP address, which will leave the machine and then come back. So let's go ahead and walk through our server here and see how this guy is working. All right, so we already have our normal standard I/O stuff. I'm bringing in this socket.h library. We have our standard lib. I'm bringing in this inet library for input stuff. So netinet has a in.h, which is stuff related to server sockets. I also have our string.h. All right, now this is something we haven't seen before. Lately, if you saw what I did before in this thing, I created a couple of variables here, file size. All right, so these are actually creating real memory for the variables instead of being at a compiler time thing. If you notice here in the server, they're defining a port called 8080. So that's like a constant, right? So I could always say something like define file size is equal to 100, not equal to. file size is 100. Okay, and what these guys are called, they're called macros. So it's something that happens at runtime or at compile time. So then at when you're compiling any place down here where you've used the word file size, it will replace it with 100 and never actually create memory for that. It'll put in the literals. So a little bit higher performance, but pick your poison. Okay, so the reason we're picking port 8080 is on a standard server. We talk about servers. Ports 1 to, actually ports 0 to 1023 are reserved for system stuff. Okay, so you basically need to be an administrator in order to talk to any of those things, to grab one of those ports. Now, several things you may have heard of are running on those ports. So for instance, HTTP is typically running on port 80. All right, so if I go to www.google.com and then I do :80 there, it'll still take me to Google. So :80 is the assumed port that you're connecting to when you're talking to a web server, because that's web servers typically run on port 80. All right. Similarly, Telnet. Anybody know what port Telnet typically runs on? It's on 23. FTP actually uses several different because of like secure FTP and stuff like that. But let's just say port 21. So you have standard ports for a lot of the different things. And what you can do is you can actually, there are some programs that are called port scanners, where you can do a port scanner on a server and see what different services are running on the different ports. It might actually look like an attack to the server, so maybe just don't do that. But you could. If you only run it once, it's probably going to be fine. You know, they're trying to detect the denial of service, probably more things are happening. But we have ports 0 through 1023 that are already going to be reserved by the operating system. That means that us, as having a normal user account on here, we are not going to be able to request one of those ports. Okay, we have to pick a port bigger than that. Okay, so we kind of have to make a guess at a port that might be available. So a pretty common thing for secondary web servers is to run them in port 8080, since the default port is 80. 8080 is kind of makes sense. So we'll just randomly pick 8080, but we could pick any number there that's greater than 1023. And we just hope that that number isn't, that port's not already taken. If it was already taken, we would fail to bind to it. Okay, so we're just picking a port 8080 there for no good reason. We're going to create a couple of integers here for our server file descriptor, for our what's going to be our new socket that comes in, and then for the value that we read in. So these are all going to be pointers to the beginning of that. You'll see how they're used here in a few minutes. Then we're going to have an instance of this struct called socket address in, and that's going to be called address. So this is something that's built into this in.h library that allows us to get information about the guy that just connected. All right. We have this option thing 1. We'll explain it here in a few minutes. Then we have the address length. This is going to be what's the size of an address on this machine. And what that means is you have IP version 4 versus IP version 6 for IP addresses. So when we deal with an address, most machines, the size of address is going to come back as the thing that's going to be the one, it's going to be 255 plus 255 plus 255 plus 255. So whatever that is that 1024? That should be 256 plus. 256 times 4 should be 1024. Sounds right? I think it sounds right. 256 times 4, 1024. All right, so that's going to be 1024 bits to hold that that address. But we're asking the system to tell us how big an address is for that system. Okay. Then we're going to go ahead and we've been creating our buffers using, I grabbed this code from someplace. So we've been you create our buffers using char pointer buffer is equal to malloc 1024 times size of char. I know this looks friendlier. We'll leave it for right now, but this is not what the cool kids write. All right, so in any case, we're just creating a place to read a string into. They're calling a buffer, which is going to be pretty common. And then here's our reply message, the hello from server, put whatever you want in there. All right, so now this is where they're trying to do some stuff. So the very first thing they're trying to do is creating a socket file descriptor. So they're setting our server FD equal to, now they're using the socket function that came in from socket.h. And they're going to try to create a, this is all address network. So this will accept any internet address as an input as opposed to saying just local addresses, things like that. So we want to create a socket, AFINet, and it's going to be a stream socket. So these are constants that are part of the socket.h library. So this is not the datagram type. This is the one that says guarantee it arrives, TCP IP stuff. I don't know what that last thing is. We can look it up, but for right now, just for time, let's just keep trucking. So we're asking, did this work? If it's equal to 0, that means it failed, false. So we say, here's an error. We print an error, socket failed. We exit the program. All right. Otherwise, if we are still kicking right here, we assume server FD worked. Okay. Then we try to forcibly attach the socket to port 8080. So we set the socket options to, here's our server thing. Here's our, I don't know what this constant is for, but this says allow us to reuse an address and reuse the port. In case you are running this thing multiple times, the port will release and you'll be able to use the same port again. We pass it our option guy from up here, which options are going to be, there's going to be a list inside of there for what the different options are. This is going to be some sort of default thing. So we're setting the socket options here. If that fails, print out an error message. Then we're going to assign some things to our struct that we had up here. So this is this socket address in struct. All right, so we're going to set the socket in family to AFINet, the socket in address to any address, and the socket in port to HTONS, which is it's a function that converts that port, I think, into like a local address thingy on the machine. And then we'll give it our port, which is 8080. All right, so we're setting up that initial stuff there. Then we're going to attempt to bind our now server socket to the address and see if that works. So this should connect it to port 8080. If that fails, we scream. Otherwise, now we're bound to it. So we'll start listening on there. If that fails, we get another error message. This is doing a lot of error checking. So we'll try to start listening on port 8080 after we've bound to it. And now we will create our, this is the internal thing. So this guy blocks. So when this program first launches and it's sitting there doing nothing, it's waiting. It's kind of like the scanf. It's waiting to accept that incoming connection. And when it accepts that incoming connection, we then create the new socket connected to our client. We read in whatever our client writes up to 1024. So I've been typing in LOL and pressing enter. We're then printing out what the client wrote, and then we're sending back to them our message. Okay, so we get the high level idea of socket server stuff. All right, so no homework for Friday, but we're going to go through this on Friday. Then you'll have something over the weekend to doctor up from this. All right, I will see everybody Friday.